The purpose of this Headless Professor video is to demonstrate the use of the Kolmogorov-Smirnov test for comparing sample versus norms, and we're going to use the Vassar Stats website to do that. So we have to start with some norms. In this case, the variable is ethnic breakdown in the city of Long Beach. And those are the norms. We know what the breakdown is citywide, and we're going to compare that to a specific sample of skaters at Bixby Park. And so let's go to the Vassar Stats site. Now, to get to the Kolmogorov-Smirnov test, click on frequency data, and then scroll down past chi-squared to another test for goodness of fit, the Kolmogorov-Smirnov one sample test. So we click on that, and just like chi-squared, we are comparing an observed frequency within our sample compared to an expected frequency or expected proportion that comes from population norms. So let's start with the population norms. We're going to enter a proportion. Now, a proportion is just like a percent, except we use a decimal. So the city of Long Beach is 42% Hispanic, so we'll put the expected proportion as 0.42. For Anglos, Caucasians, it would be 29% or 0.29. African Americans 13%, Asians 12%, and all others and those not classified would be 4%. Notice how we enter 4% as 0.04. So those are our expected proportions. Now let's enter our observed frequencies of each category. So how many Hispanics did we observe among our 13 skaters? We only observed 2. How many Caucasians did we observe? We observed 10. How many African Americans? Only 1. No Asians and no other races. So now we've got our observed frequencies compared to our expected frequencies. And we click on Calculate. Notice how it does the math and fills in the actual frequencies from the proportion. And let's check our sample size, 13. That was correct. And now it shows us at each cumulative level how the observed frequency is doing versus the expected, and then what is the difference between these two. The maximum difference at any point of comparison is this right here, the 0.266. And that will tell us whether we have statistical significance. In order to be significant, we needed to have this much difference to be significant at a 0.05 level, and we needed to have this much difference to be significant at the 0.01 level. So the conclusion would be we just don't have enough difference to be statistically significant given the relatively small sample size.